Alright, so welcome. In the previous video, we talked about the second law of thermodynamics. So we are going to be applying everything we learned there, the principle of the heat engine and how to calculate efficiencies and all that into this video. So let's consider the first problem. We have a question which says a steam turbine receives a mass flow rate of 1.35 kilograms per second and the power output is 500 kilowatts. If the heat loss is negligible, question says calculate the change in specific enthalpy when the efficiency is 80%. Alright, so let's get down the parameters that was given to us. We have that a steam turbine receives mass flow rate. So we simply have mass flow rate. Alright, so mass flow rate simply means m dot symbolically. It simply means the mass of fluid flowing within a given time, and the value is simply given as 1.35 kilograms per second. So from the unit is even clear. Kilograms is unit of mass, seconds is unit of time. So it simply means the mass of fluid flowing within a given time. Okay, and the power output was given as 500 kilowatts. So power output, okay, simply call this P out equals 500 kilowatts. Okay, you might choose to convert that to watts simply by multiplying by 1000 if you wish. All right, so if the heat loss is negligible, question says calculate the specific enthalpy change when efficiency is 80%. So we're given efficiency. Okay, we are given efficiency to be 80%. Of course, this can simply be 0.8. Simply dividing by 100, you have the efficiency to be 0.8. Now we have to find the specific enthalpy change. Specific enthalpy change is actually unknown. All right. So first of all, they said a steam turbine. This is actually a steam turbine, and for a turbine, for turbines, okay, for turbines, the work done for a turbine is actually giving us the change in specific enthalpy H1 minus H2. Okay, and this is actually measured in kilograms, sorry, in kilojoules per kilograms. So this is actually what work done in turbine. So we need to actually now convert this towards power because the power output was already given to us, or the efficiency is related to what in terms of power we have the efficiency and then we have the power output. So which means we need to convert this turbine work into power. To do that is simple. It becomes power input. Okay, that's simply by multiplying the work by the turbine, okay, times the mass flow rate. If you multiply the turbine work by the mass flow rate, we're definitely going to obtain the power input into the system, and this is simply equal to work done by turbine here is change in specific enthalpy, which is H1 minus H2. Multiplying this by mass flow rate, we are simply going to have, let's confirm this now from their units. The unit of enthalpy is kilojoules per kilograms, so you simply have kilojoules per kilograms multiplying by unit of mass flow rate here, as can be seen, is kilograms per second. So you have kilograms per second. So from here, kilograms can actually cancel kilograms. So it simply means that the power input, okay, power input is actually equal to H1 minus H2 multiplied by the mass flow rate, okay, and the unit is simply, this becomes kilojoules per second. This becomes kilojoules per second because kilogram cancels kilograms, so you have kilojoules per second, and kilojoules per second is the same thing as the unit for kilowatts, okay, which is the unit of power. You have this to be in kilowatts, which is the unit of power, because joule per second is watts, so it becomes kilowatts. So this becomes the power input, simply H1 minus H2 specific enthalpy in the turbine times the mass flow rate. That gives us the power input into the system, because from the equation we are given the power output. Now what is efficiency? Efficiency itself, okay, Efficiency itself is simply what? Since it is now in terms of power, it becomes power output, okay, all over power input. This becomes the efficiency multiplied by 100%, okay? But this becomes the efficiency, power output all over power input. Remember the formula, if it is not in terms of power, it becomes work done all over heat supplied. So work done is actually what? An output effect, while heat supply is actually an input effect. So in terms of power, we can simply call it power output all over power input. Now the power output was given to us as 500 kilowatts. The efficiency itself was given to us as simply 0.8. So in place of efficiency, we have 0.8 equals, here we have power output, which is 500 kilowatts, and if you wish to convert that, you simply have 500 by 10 to the power of 3, which is in kilo, okay, divided by the power input, and power input is simply this h1 minus h2 times the mass flow rate. So we simply have h1 minus h2 multiplied by the mass flow rate itself. Now mass flow rate was given in the question as 1.35, so we have multiplied by 1.35. So we simply have this. From here now, 0.8 is something as saying 0.8 divided by 1. It still gives you 0.8, nothing changes. So like this now, it becomes easier for us to cross multiply. 1 multiplies everything at the top, 0.8 multiplies everything at the bottom. So you simply have 0.8 multiplied by h1 minus h2 multiplied by 1.35, and this is now equal to 1 multiplied by 500 exponential 3. That still gives us 500 by 10 to the power of 3. Okay, so simply here 0.8 multiplies 1.35. So we simply have 0.8 multiplied 1.35 give us 0.5925 into h1 minus h2, and that's equal to 500 by 10 to the power of 3. So to make the enthalpy change subject, simply divide through by 0.5925. That simply means that h1 minus h2 equals 500 by 10 to the power of 3 all over 0.5925. So this actually implies that the specific enthalpy change h1 minus h2 is equal to, so you simply have 843.88, okay, by 10 to the power of 3 in watts. So this becomes the value of the change in specific enthalpy. So that's what the question is asking us to find, the value for the change in specific enthalpy. That simply gives us the answer to that question. All right, so I hope you find this video very interesting. Please, if you do, don't forget to share your thoughts in the comment section, and of course, if you're new to the channel, please hit the subscribe button to keep getting updates when content as this drops. Thanks and cheers.